Okay, this is section 2.5 in your textbook, page 113. Have your notebook out, your textbook out as well. Turn to page 113. Okay, we're learning about multiplying a polynomial by a monomial. Just to review, let's just go over what a polynomial is and a monomial. It's important that we understand the title before we go into the lesson. Who can tell me what a polynomial is? No? You guys have had a couple lessons on this now. Polynomial, anybody? Kevin?
One term or the sum of two or more terms.
Okay. Good. So you read that description? Did you look it up in the glossary?
No, I just have notes.
Does anybody have the glossary definition? It's always the easiest way to answer, right? It's a good communication question for you guys. We have the textbooks open, out, glossary definition for polynomial. Josh?
An expression that comprises a sum and or difference of monomials.
Okay, so that doesn't help us too much if we don't know what a monomial is. Does anybody know what a monomial is? Yeah?
Next, algebraic expressions with only one term.
Okay, good. So, a monomial, let me put it down here, monomial, is just one term algebraic expression. Okay, we don't need a super fancy definition. So, an example of that would be 2x, or 2x squared, or y cubed. Alright? These are all examples of monomials. When we get into polynomials, put right underneath here, polynomials. So it's two or more terms in an algebraic expression. Okay, so an example of polynomials would be 2x plus 3, or 3x to the power of 4 plus y squared. Okay, you see the pattern? Or we could say 3x plus y squared minus 10x cubed plus z to the power of 5 minus 800 w to the power of 1000. Okay? That's a polynomial. Yeah, it's very long, but it's got more than two terms. Okay? It doesn't matter what it is. As long as it's got two or more terms, it's a polynomial. Alright, so we know what a monomial is. A polynomial. Who can use deductive reasoning and tell me what is, put it over here, a trinomial, which will be your best friend in grade 10. A trinomial. Alright, half the class. How about on this side? Chris, what do you think?
It's a number with two.
No? It's close. I'll put that one over here. That one's called a binomial. And when you're bi, you go two ways. So we got two terms for binomial, right? Kevin?
A polynomial with three terms.
Good. So three terms. Three terms in a algebraic expression. So examples would be 10x squared minus 3x plus 7. Binomial, two terms. So 5x plus 10. Okay? Doesn't matter what the exponent is, whether it's 2 3, 5, or 1,000, as long as there's two separate terms. If I say 5x squared plus 2x squared, is this a monomial or a binomial? Michael?
Binomial.
It's actually a monomial, okay, because we would simplify it first, right?
Oh.
So it's a bit of a trick question, right? This would actually be 7x squared, right? You see that?
But that's when you're
So-
answering.
Yeah, so non-simplified terms, you could argue that this is a binomial because it has two terms, but you would want to simplify that first, and the correct answer would be a monomial. Okay? You guys good with that? We all know what a monomial is: trinomial, binomial, monomial, and polynomial. So, if I said trinomial, is this a monomial or polynomial? Polynomial, right? So a trinomial is a subset of polynomials, okay? It goes underneath, right? Same thing for binomial. This is also a type of polynomial, okay? Any questions? Binomial, trinomial, monomial, polynomial? Yeah.
Just keep going on, like, quadnomial.
Quadnomial, yeah, you probably could. I personally don't know any other terminology. I think after they get past trinomial, they just call it polynomial. But you're right, using the same logic, you could maybe call it a quadnomial. I just never heard that expression before. Okay? All right, so we're looking at multiplying a polynomial by a monomial. So what that means then, in math terms, is you can see here is a monomial, right? This is the monomial, the 3. And the polynomial is over here, because it's 2 terms. Okay? Could also be 3 terms in this bracket, right? It would be a trinomial, but it would also be considered a polynomial. Is that clear to everybody now?
Yeah.
So we understand what we're trying to figure out to do here. So it says determine the product of 3. Remember, bracket, when you have a number right next to a bracket, there's a multiplication here. And for the purpose of this lesson, I'm kind of moving forward. Because we use x so often, we do use x so often in algebra, I'm going to kind of use this dot to represent multiplication. Okay, you're going to see it over here. I use it over here. It's actually another way to represent multiply. It's a solid dot in the middle. When we have brackets, we don't need that dot at all. We don't need anything. It's understood that this is multiplied. Okay? So we want to know 3 times 2x plus 4. Well, if we use our algebra tiles and we know that this is 2x plus 4, remember the larger tiles represent the x variable, so we have 2 of them, that's 2x, and the smaller little tiles represent just the numbers by themselves. So in this case we have 4. So 2x and 4. Well, if we have 3 times 2x plus 4, then we know we have 3 2x plus 4s. Okay, so that's what I'm trying to represent here. Here's 1 2x plus 4, 2 2x plus 4, and 3 2x plus 4. Okay, so we know if we add these 3 sums up, we'll get the same value as multiplying one of them by 3. Does that make sense? Hope that's pretty clear. I'm just going to show you guys this one time, likely, with the algebra child. It just allows you to answer any questions you might see in the homework with it, but I don't use them often, as you guys know. But for some of you that might have a hard time looking at kind of what this actually means, this might help you out. Okay, so if we gather now all the common terms, the like terms as we say, we're gathering all the x, so we're grabbing all those 2 and we're putting them down together. I reduced them in size a little bit, but you can still tell that these are the 2x here, 2x here, and 2x over here. Okay, so that's what these arrows are doing. Okay, so now we've collected all the like terms, all the x's. I can add those up, 1, 2, 3, 4, 5, 6, I get 6x, and then I take all the individual tiles, which represent just numbers, and add those up and I get 12. Okay, so my answer, you can see here, mechanically we figured it out, is 6x plus 12. We physically, using algebra tiles, we can do that. Okay, now an easier way, and the proof and point of today's lesson, is we're going to use what's called the distributive property. Okay, and it's defined by when a sum is multiplied by the number separately and products are then added. So when a sum, so this is the sum, okay, or we could have a difference, it could be a sum or a difference if this was subtraction, it's multiplied by another number and added separately. So I like to think of it like this, we draw these little arrows. So 3 multiplied by 2x and then 3 multiplied by 4. So that gives us 3 times 2x plus 3 times 4. And the reason why it's plus is because there's a positive sign here. So that gives us 6x plus 12. All right, notice that these two answers now are the same. Any questions there? So who had a hard time with this? Someone was mentioning to me, was it Michael was having a hard time with the polynomials? Somebody mentioned that they were having a really hard time on con. The video didn't help. Was it you? Is this clearing it a little bit up? Okay, hopefully by the end of today's lesson it'll be even clearer. So example 2. Now we have a, what's this called? Out loud. Trinomial, also known as a polynomial. Very good. Okay, so it has 3 terms, so it is a trinomial. It's underneath the category of a polynomial. We have the 3x squared on this side. I don't like that. Okay, the book set it up like that. It's just probably to confuse you guys. But it doesn't matter. Okay, you can multiply them like this. Okay, but I just don't think it looks right, and it's kind of a little bit backwards. So all I did was I moved the 3x to the other side of the bracket. See that? I just moved it over. Okay, you could maybe even do that in your head if you want. But as we know, 3 times 5 is 15. 5 times 3 is 15. Right? So when we're multiplying, it doesn't matter the order. Right? So I can do 3x times this, or I can do this times 3x. It just makes more kind of sense in my mind to multiply this direction. So that's why I've taken that 3x and I moved it over here. Okay? Notice I didn't change any signs. I didn't jump over an equal sign. I didn't do anything. I just moved it from there to there. Okay? Yeah?
You don't multiply the powers, you just multiply the numbers.
Multiply the what?
The exponents.
Yeah, you do. Yeah, you do. I'll show you that. Okay? So now we have 3x squared times 2x. So you see here, I've just written it out. This is an extra step I'm just showing for the purpose of today. You would put this step in your head as you do this. Okay, as this times this, this times this, and this times this, you jump right to here. So let's just show that step for today. 3x squared times 2x cubed plus 3x squared times 4x, and then plus 3x squared times negative 5. Okay, Daniel.
Sure, where'd you have to simplify that answer?
This?
No, the one in the...
This?
Yeah.
I'll talk about it. Wait till I get there. Okay, you're just one step ahead of me right now. All right, so now I'm going to multiply them out. So 3 times 2. Remember, when we multiply 2 terms, we treat the numbers separately than the variables. Okay, so in this case, we're multiplying the 3 and the 2, we get 6. And then we're multiplying the x squared times the x cubed. When we multiply 2 powers with the same base, what do we do with the exponents?
Add them.
We add them. Right, so this x squared times x cubed becomes x to the power of 5. And that's because 2 plus 3 is 5. Okay? Next, 3 times 4 is 12. X squared times x. Remember, there's a little 1 there that you don't see. So 2 plus 1 is 3. Okay, so we actually are multiplying the variables as well. Okay, somebody asked me, are we multiplying those as well? We are. This is how we do it. Next, we have 3 times negative 5 is negative 15. I don't have plus negative 15. I can get rid of the plus at that point and just put in negative 15. Okay? So we have negative 15, and then we have x squared, and there's no x to multiply. So it's just multiplying to 1, so it stays as x squared. Okay? Any questions there? Pretty much the heart of it, yeah.
Would it be wrong to put plus negative?
Yes, yeah. That's the wrong kind of term, wrong nomenclature at that point. It's a bit of a semantics, but yeah, it should be negative 15x squared. It get very confusing if you have plus minuses everywhere. Okay, yeah.
To simplify the answer, wouldn't it be 3x times?
No, you can't simplify anything here. You're done here. And the reason why is because none of these terms are alike. And the reason why they aren't is because the x has a different exponent. Okay? What determines whether the two terms are like or not is based on the exponent. First of all, x has to be the same. Can't be x and y. And the other thing that has to be the same in order to add them is the exponent. Okay? So like when we went back to this type of geometry, remember we had the big X was a big square like this? That was x squared. You can't add an x squared to an x. Okay? Do you guys get that?
Yeah.
And then when we went to x cubed, remember it was a cube, so you can't add these two because they're not alike either. Okay? Make sense?
Yeah.
So this exponent then is very important. It determines whether you can combine the terms or not. All right, next question. It says calculate the area of the trapezoid. We know the formula for a trapezoid is 1/2 times the height. And then in brackets, a plus b. So multiplied by a, this is being, in this case, a, and this is being b. Okay, that formula you guys need to know. You need to memorize that. Okay, just like formula for area of a square, which is length times width, you know the area of a trapezoid. Yep,
So isn't it a plus b times height divided by 2?
same thing.
Oh, same thing.
Yeah, yeah. You could put this over 2. It's the exact same thing. Okay. All right. So now we're just going to sub in the values. We can see h here is actually x. So I sub in x for h. A is also x. Sorry, I have this as a. And this is b. Doesn't matter either way. It would give you the same answer. So a is x plus 4. No, I did have it the other way. Whatever, you guys get the point. X plus 4 plus x. So these two values added. Now, before I use the distributive property and start multiplying these, I want to work within the brackets first, just because bedmath tells us to. So I want to combine any like terms I can. It makes my job easier. So I see I have an x here and another x here, so I know that that's 2x. So definitely want to do that first. And then we're going to add that 4. I can't combine it because it's not like, so I'm left with this situation. And now I need to use distributive property. So 1/2 x times 2x. I didn't write it out. I skipped that step, but I know 1/2 times 2 is 1. So I have a 1 there. I don't typically show it. And then x times x is x squared. Again, adding those exponents of 1. Finally, the last step, I have 1/2 x times 4. 1/2 times 4 is 2. And then x times nothing, or 1 in this case, would just be x. Okay? Any questions there? So we can get, knowing this now, we can do questions that get a lot more complicated. I'm just going to finish up with this last example. Here we're looking for the unknown variable. Okay? We need to know what multiplies by 2x squared to give us 8x cubed. That's all I need to know because I know the 5 will follow suit. So I've taken that part out of it. So I say, what multiplies by 2x squared to give us 8x cubed? Here's my new equation. Now to find out what that blank space is, I need to divide both sides by 2x squared. Okay? And the reason I do that is because now these 2x squares cross out. And I'm left with the unknown. So if I take 8x cubed and I divide it by 2x squared, the 8 divided by 2 is 4, and the x cubed divided by x squared is just x to the 1. I don't need to show the 1. Okay? That's it.